All right, I think I'll go ahead and get going. We still have 1 minute, but I think we have plenty to get to. So yeah, you are in the right presentation. Like the name of it, originally I gave us Safe Flights and Firey with JDK Flight Recorder, but I'm like, eventually this is probably gonna be like a plane wreck like a week before one of my presentations, and I'm like, that's not a great name. And also, I think taking off with JDK Flight Recorder better describes what this is, which is kind of an entry into JDK Flight Recorder. How many people have used JDK Flight Recorder before? A good chunk, but a good chunk haven't. So, and even for you who have used it before, I think there'll definitely still be some useful things. But most people aren't experienced with JDK Flight Recorder, so having an entry into how to get using it within your applications in that organization would probably be most appropriate for everyone. And we'll also see a bit into that safe flights and fire regs, where how JDK Flight Recorder can help you when it comes to finding and diagnosing issues. But yes, my name is Billy Korando. I think I see a few people from my presentation yesterday. I always take that as a positive sign of like, oh, that person had no idea what we're talking about. I'm never going to see him again. So if saw the first presentation coming to the second one, I take that as a somewhat positive sign. I'm a Java developer advocate with Oracle, and you can find me out on the Bird app, Twitter, where I spend way too much time at Billy Korando. Important information, ask questions. So like the first 5 to 10 minutes of this presentation, it's going to be just some slides, but after that, we're going to get into, I guess, live coding or just really more of a demo. So definitely ask questions as things come up, and I'll be hopefully able to answer them and go into them. And of course, to find this presentation is at that link. So you can kind of refer to this later, and then it also includes links to like some of the code examples I will be showing later. If you would like to know more, so the JFR or the Java DevRel team at Oracle, we launched dev.java back in last September, where we have a lot of great tutorials and information. So definitely check that out, and also ways of community to find like your local jugs, or also great conferences, also like Spring I/O. We also have Inside Java, and that is where we get, it's like a bunch of information mostly about from the actual developers on OpenJDK itself. So there's actually some really great interviews and information and deep dives on even things like JFR. So definitely worth checking out. And then we also have a YouTube channel where we post a lot of great videos as well. So the agenda, like I said, we're going to just quickly kind of give a high-level overview of what JDK Flight Recorder is, and then the configuring and using JDK Flight Recorder, analyzing results, custom events, and JFR event streams. That will all be kind of within the demo portion of it. So what is JDK Flight Recorder, or JFR for short, which is generally what I'm going to be referring to it going forward, because that's a whole mouthful. Oh wait. There we go. There. So initially, it was added to the JDK in JDK 7. At the time, it was then called Java Flight Recorder. So if you have heard referred to as Java Flight Recorder before, that was correct. But in JDK 11, it was renamed to JDK Flight Recorder. But it goes all the way back to the JRocket days. And that's the original team that developed it, and kind of the history kind of goes back to it of like we would hear things back, or the JRocket team would hear things back from like customers saying like, oh, we're running into these weird issues or something like that, and there would be no easy way of trying to figure out what was going on. So they kind of developed a tool that can allow giving really detailed information that can then help resolve issues. And then it's also even a tool, it's something that's very much dog-fooded, both then and even now by our JVM engineers, as a way of actually seeing what's going on within the application, or within the JVM, along with the Java application itself. So like it's not just something that we kind of put out there and don't use. It's actually heavily utilized by our own in-house engineers as well. So it gives very detailed information, and it's actually built into the Java runtime. So all your JDKs that you have, at least since well, actually even before 11, but since 11, it's now open source, so you don't even need to have a license to use it in production. So what is a JFR? It is an event-based diagnostic and profiling tool, but one of the major things, it's kind of just like its namesake of a flight recorder, it's meant to be used on every flight to always have information recorded within it. And the way it can do that is that it has an extremely low overhead of under 1%, though, as you see there's a little asterisk, which is when using default settings, and the default settings still provide very detailed information. But if you change those settings, there's there's two built-in settings. There's default and profiling. Profiling obviously gives more detailed information, and you can provide your own custom settings as well. So when you start to do that, whether or not it stays under that 1% will, your mileage may vary at that point. But like I said, it's meant to be used continuously in production. It's not supposed to be only maybe something used when something comes up, though, maybe that is sometimes what happens. But it also covers both the Java applications itself, but then also what's actually happening within the JVM as well. It's not just very lightweight. It really gives, again, a lot of detailed information that we'll see here in a few moments. But yeah, under the hood, the events, again, are produced both at the Java runtime and at the application level. And the way it maintains this 1% overhead is that all this stuff is stored in thread local buffers in memory, and then it's occasionally then dumped to a JFR file to where it can then be analyzed. As of JDK 18, there's over 150 different built-in event types. And I mean, this is obviously just a small collection of that, but things like system processes, garbage collection pauses, if an evacuation failed, thread starts, thread dumps, file reads, file writes. It covers a whole very wide variety of different events and event types. So again, very detailed information. With that said, let's actually properly get into the demo. So to get started with JDK Flight Recorder, and let me expand that in size because I know that is way, way too small. That's how I want it. It's always important to have a cheat sheet when you're doing live demos, just so you don't forget exactly what you want to do. So there is the start flight recording event, and so or the JVM flag, which obviously given its name, that is how you would start a flight recording at the start of when you're running an application. And then you would then provide a name for that as well. If you don't provide a name, then a name will be generated. It'll be like hotspot, and then it'll give like the process ID, and I think maybe the date of it. Here then there's also, I have dump on exit, so that means once the JVM exits, then it will just create that recording file. Up until then, all that information is stored in memory. And then of course I'm just running the Spring Boot Pet Clinic app as well. And that's what we see here up at the start of it. This is JFR saying, oh, it started up. And you can also use jcommand, which I'll get into a little bit, to also kind of work with JFR for already running applications. Let's see, actually. Go to localhost 8080, and again, it's just the Pet app that the Spring team put together. Just an easy demo that just provides some simple REST endpoints for doing some things. So just not really doing anything important here, just providing a bunch of events. But if I go ahead and now stop this, then we'll see. Actually, I need to clear that one out. But we see the recording JFR was created. So to analyze this then, there is several tools for doing this. JDK Miscontrol is a GUI app for doing that. And that's actually using an older one. Yeah. Let me open the one I just created. And this is providing a good way of a good overview of what the application has done, say like the number of threads, amount of memory, and stuff like that. But as I mentioned, so here there is the Java application level, JVM internals, and then the environment. So like I said, it provides multiple different levels into what is actually happening within your application. And this can also then provide ways of then analyzing maybe what is going wrong with the application, or providing ways of finding issues on ways you can improve performance. But like the threads are executed, memory, kind of where everything is being stored. You'll see here it's in byte arrays, and that's because that means it's a thread. So most applications are not threads, but a string. Most applications, most of their information will be stored in byte arrays, because that's kind of, since JDK 9, how string information is generally stored. And of course, we can go into JVM internals as well, to where we can see like how often garbage collections are occurring. And as we can see, many garbage collections, even that short amount of time occurred. We can see information like GC configuration and GC summary as well. So one of the things I covered in my presentation from yesterday is how we have a new garbage collector that was added in JDK 19, or not JDK 19, JDK 15 GGC. So plus use GGC. So let's go ahead and start this application up again. But you'll notice I accidentally, let's just say I forgot to start Flight Recorder when I started up the application, or maybe your application's running along fine, and then all of a sudden you're starting to notice issues in production. Having to go and then shut down your application and then restart it, well, you may end up losing information on what is going wrong with your application, or that may take a long time to do that. So one of the really nice things is with the JCommand tool, first we will need JPS, and then JDCommand tool, JCommand, we can actually go ahead and start flight recording on a in-running application, in-process application. So here is our running application. I looked it up with JPS, which looks up running Java applications, and its process ID is 5678. So let me go back just to the cheat sheet, just so I'm not going to mistype something. But here, I can actually start up an application, or start up a flight recording again on an in-process application. So that is one of the really nice things, is that you don't actually have to go back and again start up your application to start flight recordings. You can again do it in process as well. So yeah, and in this case I did GGC just to kind of compare also how you can see the difference between using different garbage collectors, how that would then look different within the analysis of the application. And we'll go back to, again, the Pet Clinic app and just do a few things. Again, it's really not important what we're doing. We're getting some vaccinations for the dog, whatever. Edit pet, and it was actually born 2013. So there you go. Wow, 2012, that would be a very long-lived hamster by this point. So, and then we can also, as it shows here, we can also dump a file as our perform a dump to get a recording out of a live running application, so we don't necessarily have to stop the application to be able to start analyzing it. So we'll go ahead and do that, and we'll open that up then as well. But yeah, we can kind of see here the differences between, and this hasn't even been any GC pauses. Maybe I should go ahead and do a few more things. Maybe I actually would want to start it up just to kind of also show some of the additional behaviors as well and differences between the different garbage collectors. Ooh, actually, I know what we can do. There we go. Maybe that will also help encourage some garbage collectance. Well, I'll go back and run that again. Or actually, no, I will stop the application and start it up again. And so along with this flight recording here, only show a couple commands, but there's a whole lot of different commands you can also, or a whole lot of different options you can actually put within the start flight recording command to give different properties and behaviors to how your flight recording will occur. For example, you can provide different settings files as well that again will capture or give different levels of details for the events captured. And it was born just recently. There we go. Now we should actually probably see some more. Yeah, this can also show you a way as well of like how the different behaviors between say like G1, which does a lot more garbage collections, and GDC, which is a little bit less often when it's doing garbage collections. You can also see, I think I mentioned like yesterday during my presentation, if you were there, like one of the goals of like ZDC is extremely low pause times. And you can see here, like the longest pause times are like 12 microseconds or 34 microseconds compared to the pause times of G1, which has pause times in the order of like 4 or so milliseconds. Of course, there's different goals, like G1 is more about being about throughput and a little bit more balanced, whereas ZTC is very much focused on pause times. But, you know, this can just show you also how, if you want to compare other ones, like you want to compare like parallel or maybe serial for some reason, you can also use JFR to kind of go in there and do analysis on what's actually happening within the application. You can see also here how the heap is, you know, with all these pauses, like how it's rapidly controlling the heap to keep the memory as low as possible, whereas that's happening a couple times within GDC. It's less concerned with conserving heap space when compared to G1. So this is, again, can show you some of the ways as to how JFR can help you with figuring out what's going on within your application. So, of course, when we're mostly going to be using JFR is when issues come up. For example, like maybe I put into like this way to leak some threads, or of course maybe even leak some memory as well. So I leaked a bunch of threads. Just before today, I almost crashed my laptop because I leaked too many threads, and all of a sudden my laptop was about to take off because it had no more threads available to it. So, you know, you want to be careful when you put together demos like this that you don't also accidentally almost crash your system. Okay, that was correct. So we go back in here, and I just go ahead and open this back up. I gave within the code itself, I told it to give the name of dead thread. So it's not like JFR, the system would know that this thread is in fact dead. Unfortunately, for some reason, there's an issue within the JDK mission control where it doesn't show the stack trace, which is unfortunate. There's some sort of bug, but we can still see it. So there's also the tool. So like JFR is really, our JDK mission control is really great for providing that overall analysis of what's happening within your application. But then there's also the JFR command line tool, which we can also go to for also doing some more command line analysis of it. And luckily for it here, so the information is actually being recorded by it. For some reason though, like I said, JDK mission control is just not showing it. That's not what I wanted. The GDC recording. Oh, I'm not in the correct directory code. Oh, yes, I will do that in 1 second. Thank you for mentioning that, though. Is that big enough for everyone, even in back? Perfect. Thank you for saying something. Now, there we go. So I can go in, this will read the recording file. I can just provide another way of analyzing the recording file. And then here you'll see this can provide like a stack trace of maybe what is happening. And that way, if like, oh, okay, we're having some sort of a resource leak, you can actually get into the stack trace and then it's like, oh, okay, I mean, you know, this is pretty obvious with the JFR controller leak threads. You know, wouldn't always be that obvious, but this could be a way of analyzing, okay, we're having some sort of slow memory leak over time. You can use JFR to actually kind of go in there to maybe see, wait, where is maybe some of this is suspected of happening? And even in JDK mission control, you would be able to see here, like this is how long they've been alive. You can perhaps see these really long-lived threads or resources, whatever you might be looking for. You know, of course, it could be like file O where something's just not being let go. And then even if maybe, again, unfortunately, for some reason, there's a bug not showing the stack trace within here, you can then use like the JFR command line tool for then figuring out, okay, what is going on. But also here, is this updated integer? You know, if I was to run the memory leak thing a whole bunch more times, it would end up showing like a huge amount of memory being allocated to integers, or, you know, maybe whatever kind of memory object that you may be having, something that's not being properly garbage collected. So again, this memory map area could be another good area to go to see like, hold on, you know, kind of as I mentioned earlier, like threads usually should be, or strings should be the biggest thing on your heap. And if there's some other item on your heap that's unusually large looking, again, integers having 24 megabytes or megabits assigned to them would be unusually large. This could be a good way to go in to say like, hold on, there's a little bit something wrong here. There could be ways of improving the efficiency for this. So I mentioned how, and actually let me go ahead and kill this because my laptop is starting to take off because it's running 100 concurrent threads. I mentioned there's 150 predefined events, but you can define your own custom events as well. And simply all you need to do to that is extend the event type. And then you can provide your own fields within it, like I have within here, the important value field. So the field types within an event, they can be string, class, thread, I think that's the other one, and then it could be any of the primitive types. Any other types outside of that would be just quietly ignored. So when it causes some sort of error, it just simply wouldn't be recorded. By default, an event is enabled, but you know, here if I was to put the enabled false on there, then within the settings file or the command line, I could then selectively enable it. You can also then provide meta labels with like category label and as others for ways of being able to look up the event type. Like here, so I have like events. In this case, because I didn't provide like a custom name, because I think there is like an event name label or something like that. But by default, the name of the event will be its fully qualified name. But there's also ways where I could do like categories here as well for filtering the events from within JFR or with the JFR command line tool. But this can be a very good way for getting custom information out if you need it. And then within your actual code to do that is you would then do, you would create a new instance of your event. Then you would call event.begin to start recording it, and then event.commit to assign it. And from there, you can just, here in this case, I'm assigning like a value, like the numbers of threads that are being dead threaded here. And you can collect whatever pertinent information you want at this point. Now, this does look somewhat messy and heavyweight, and so you might be thinking like, oh, okay, maybe I'm going to do that, but then this may cause like a lot of overhead within my code. However, it really doesn't. Despite this being somewhat messy from a code perspective, it would actually have very little impact on the overhead of your code. If your event wasn't even enabled at the time, the JIT compiler will basically ignore all these commands to where they just won't even be executed at all. And if it is recording, again, it's very lightweight because, like as I mentioned at the start of it, this all is being recorded into thread local buffers. So the amount of impact it has on the overhead is relatively low, though the biggest things that can affect overhead is the stack depth as to what you're recording. If you start recording very deep into the stack, then that can actually start to begin to really affect overhead because that's starting to take a bunch of processing to record up through the stack. So another thing that was then, something I forgot to mention in my presentation yesterday that was added is now there's also JFR event streams. That was added in Java 14. But so far, kind of way we've shown, you would run it, and then if I wanted to get information out of it, I would have to perform a dump on it. And of course, you wouldn't necessarily want to be performing dumps all the time, like every second or every minute even. So getting information out of it isn't a very live process. However, there's now JFR streams, which can allow for the live retrieval of information from it. And a simple example of that then is the health report, which is just an example put together by one of our JFR engineers, where we can attach it through the Java agent tool to provide live analysis on a running application. And once that starts up, it'll look a little bit less. Oh my, that looks pretty strange. It's not formatting properly. Let me run a few things. Well, sorry, it's weirdly formatted. I haven't ran it maybe with this size of font on it before. And this is really ultimately just an example, but like in this case, it's showing live results coming out of like the CPU usage, how much physical memory is using. Ultimately, not necessarily going to maybe use something like this because I think this could be relatively heavyweight in the amount of overhead it is using. When it comes to the JFR event streams, there's many ways of using it. Like you can, in this case, I have it attached through a Java agent. You can also have it to where the events are writing out to like a disk space, and then like some other event isn't reading from that disk space. You can have it being processed over JMX as well. There's a lot of flexibility in how it works, and there's also a lot of flexibility when you create event streams and what events you're capturing, because you're not necessarily maybe wanting to capture everything. There could be very specific things you want to capture that maybe only really matter to certain things or key metrics that you're looking for. So there's a lot of flexibility. When you're writing stuff out to disk space, the amount of overhead that's going to cause is going to be relatively low, because most of the processing then will be on maybe some external event type when it's, or some sort of external process when reading it. That's going to take where most of that overhead is going to come from. But if, say, you're writing it out to like a JMX socket, there could be a bit more of overhead involved there, because you're actually then having to serialize all those event types as you're writing it out. So that is, again, also something to keep in mind if you're wanting to do events, is to make sure, or use event streams, is to kind of keep in mind some of the potential overhead implications involved in that. That 1% I talked about earlier may no longer be true depending upon how it is implemented. Another thing also with JFR is that there's a couple of big changes that are coming to Java. Two of them would be how finalization is being deprecated for removal. That was added in JDK 18. And to help prepare for that, the JFR team added a new event type. If you find it in the JEP, or let me actually just go ahead and look up the JEPs. I believe it's in there. So yeah, JFR they created a new event type, JDK finalizer statistics. So that is a way of finding where finalization is being used within your application, whether the application itself or, of course, all the underlying dependencies. Because, like I said, finalizer is being removed, and that could be a way of tracking down maybe a potentially problematic use of finalization within your application. Another is also with Loom, with the move to using virtual threads. A lot of things, like if you're doing some sort of certain things like file I/O, where you can maybe be accidentally holding onto it, and you have like a bunch of virtual threads all holding on to maybe a thread, a file I/O thread or something like that. That could be a huge issue. So they also added a few new event types as well to potentially look for and find any sort of maybe potentially problematic issues within your code as to that could cause issues as Loom is properly delivered into the application, hopefully here within the next year or so. Currently with JDK 19, that would be a preview feature, but hopefully, fingers crossed, that will be actually delivered as a regular feature with JDK 21. That's it. Does anyone have any questions? I can kind of continue going on with a couple other things, but I don't know if, yes, right here. I think, yeah, here's the first, so, and we'll go back, I guess.
Yeah, so two questions. The first one is this a standalone tool, or is it part of the hotspot VM? And the second one is, would it be affected if I use like JLink to create a custom runtime for my app?
So it's actually built into the JDK itself. It only works with the hotspot JVM. So if you're using our hotspot derivative JVM, so if you're using like a different JVM, like say OpenJ9 from IBM, JDK Flight Recorder wouldn't work with it. But yeah, it is actually built into all images of OpenJDK. And what was the second part of your question?
Like if I create
Oh, sorry.
If I use JLink to create a custom runtime, and later on, as you said, like if I can send the command to start recording later on?
That is a good question. I actually haven't tried that. There would be, I guess, a possibility that that wouldn't then be part of it. I guess it kind of would depend upon how you write the JLink to cool, whether or not it includes the JFR modules within it. So yeah, I don't know. It could be a case that that's always going to be included with it, just because that's something the JVM itself uses. All right, great questions. Anyone else? Oh, right next. I'll get to you.
Hello, is it compatible with native compilation, all of the GFR stuff?
With native compilation, like in GraalVM, I don't think so, because GraalVM is a different JVM from Hotspot. So I don't know. I don't think offhand, or unless they did do some sort of compatibility work to create their own instance of or example of it. So.
Okay, and I have a second question. Do you think it's a good idea to add some business event tracking on my application?
Maybe. It really kind of comes down to maybe what you're looking for. But like I said, it's very lightweight, that if the event isn't enabled, like the overhead to your application is basically nil. Especially if, you make sure you put like maybe some ifs around to enable if you're doing some sort of more complex behavior, so that complex behavior isn't being captured. But yeah, it's probably something that is definitely overlooked when by many developers, including myself, until I really started learning about JFR recently, about a good way of doing performance analysis or find performance issues is to create a custom event around an area that you think might be having some sort of issue, and then capture some information and maybe figure out what is going on. It can actually, I think, be also a much more lightweight way of doing logging. So the capturing of event types, like there's another presentation by like some of the JFR event lead, Michael Vitstead. I think I had the link at the end here of the presentation, and actually I'll go ahead and go to that just so we can see the link. I think it's in here somewhere, but all the same, where actually like capturing an event is like orders of magnitude faster than like writing to a log for like any of like log for J or SL for J or anything like that. So it can also be a better way of collecting information than just doing standard logging. So I think we had a question over here. 1 second, I think with the microphone, they can actually be captured in the recording as well.
Okay, the sub 1% overhead, was that memory or processing?
I think that's mostly from processing. I guess I don't remember if that's ever specifically said, but I think they're really kind of referring to throughput in that example of the sub 1%. But I think that's also a question I can maybe also ask the JFR team to say. It's been a little bit ambiguous when it's been described, but I think it's the throughput perspective. All right. Any other question? Yeah.
Hi, thanks for a really nice presentation. And my question is, if you will have to compare JFR to other profilers like Visual VM or JProfile, what would be the biggest advantage here? I mean, is it this low impact on performance, or more data is collected, or? Yeah.
So because JFR is actually built into the JDK itself, that provides a big advantage that it can get a lot deeper than most any other tool can get into. And then certainly the extremely low overhead also encourages its use. Like really, ideally, even like the JFR team and many others, like really go ahead and start using JFR in production like right now. Like, again, it's sub 1%. It's such a low overhead that there's going to be much more benefit to using it than to not using it. I mean, if you have some sort of rock solid application and performance is absolutely crucial, in that case, maybe turn it off. But really, for 99% of your applications, you really should consider going in and turning on JFR recordings, and then actually occasionally performing dumps to start analyzing your applications. So those are two big advantages. I don't know enough about JProfile or some of these other tools, so I don't want to really because I always find sometimes the comparisons are very difficult because like, oh, okay, I know JFR really well, so I can talk about its strengths, but I don't know, there could be particular advantages to those as well. So sometimes it's just going to come down to what particular use case you also have as well. Any more questions or, yeah, right.
Yeah, first, thanks for the presentation. For the custom events,
Yes.
they were quite annotation heavy. Do they have to be known at compilation time, or can we define them on the fly, for example, in other JVM languages dynamically?
So would they have to be known? Well, they would have to be on the class path for them to be available. So, I mean, I guess through something like a Java agent, you could maybe manually add something in, you know, post startup. But yeah, generally it would probably have to be known at compilation time. As far as the annotations, really, you don't have. I mean, I could take all these annotations off and it would actually work just as well. The annotations would provide metadata generally for being able to better look stuff up, because without it, without like saying like, oh, here's my custom events, then, you know, I would have to look it up maybe by the specific event name to actually look it up. About the only one, like I think enabled, I think there's a couple that would actually have like functional implications, but most of them, it's just about providing metadata.
Thanks.
Yep. Yeah. Any other question? Let's see. Custom event. Yeah, I think I got it. Okay. Well, if there's no other questions, again, let me get back to the slides. If you have any questions, you know, feel free to reach out to me on Twitter or feel free to email me. And the link to this presentation, which then also includes the code example that I use, is also right here, along with a bit of a little cheat sheet I have here as well for some of the commands I ran. So you can definitely check that out as well. Also, I guess I should say, oops. I mentioned there's also different settings files you can have. And oh yeah, here it is. So I mean, it's a .jfc file, but obviously this is written in XML. And there's two default, like I said, there's the default settings, and there's also profile settings. Profile obviously is going to be capturing a lot more information. So in that case, that 1% mark would likely be gone over. But here, like for this, when I initially showed the annotation with it being disabled or turned to false, this is a way I can then enable my event to be captured. Another way is also through command line, and I can provide an example of that as well. But yeah, there's a lot of different ways you can also configure like how much stack you're going to collect, like the threshold of like how long an event has to run. Here in the code example. So here, when I do the begin and commit, at least by default, the only information that's being captured is the stack and then the event duration. And let's say, kind of to your example of, you know, creating custom event types and to maybe collect information, you may be like, okay, if between the begin and the commit, it all lasts under 1 millisecond or whatever time makes sense for you, don't capture it. So like there's this threshold to say, yeah, if it, you know, I have mine set to 0, so obviously it's going to capture everything, but you could be like, okay, if it's less than 10 milliseconds, don't bother capturing it because that's not that important. That's kind of the expected performance. But if it goes over that, then it will be captured. So that's also a way of making sure you're not just going to be collecting way too much information. And of course, that's not just your custom event types. That could be obviously any event type within here as well. You can create your own settings file to, you know, collect information that makes the most sense to you as well. Also, another thing, it is also being updated so it can properly work with Loom. It's going to be a bit of work because whereas, you know, there would typically be dozens to hundreds of threads before, they're kind of working on better being able to show potentially up to many thousands or potentially millions of threads that could be happening within the Loom world as well. So I know it's updated to where it can at least somewhat properly collect it, but there could still be some ongoing process to make sure it can be more legible, like when seen within JDK Mystic Control. Like I said, if you have any more questions, feel free to come up after here or DM me on Twitter or send me an email. I'll be more than happy to answer any questions you have. So yeah, thank you.